far we've talked about solving systems of equations by graphing. And by graphing, we can find that point, that xy ordered pair that is on both lines or is a solution to each equation, really is what that is. Now, if you have a calculator especially, this is a nice way to do it because if you have a calculator, even if it's a decimal, you can do the menu, analyze graph intersection to get the decimal place where they intersect. However, you're not always going to have access to a calculator. There are tests that you need to take with no calculator, or there may be other situations in your life where you want to solve a system of equations, but you don't have a graphing calculator handy. If that's the case, another way that you can solve systems of equations, even if the answer is a decimal without a calculator, is with substitution. This works well when one variable is already isolated, which means all by itself. You can substitute its value into the other equation. Then you solve to find the value of that first variable, and then you plug that value into either equation to find the value of the other variable. This is nice to use when at least one of the equations is already solved for a variable. So there's 3 real steps. I'm going to number these as 1, 2, and 3. This first one is easy to solve with substitution because we already have this x all by itself. So if I know that x is equal to -7, that means they're the same. Because this equal sign tells me they're the same. That's what an equal sign means, is this is the same as this. It might look different, but it really is the same. So when two things are the same, we can substitute them in and out for each other. Just like when we're cooking, we could substitute butter for margarine because they're the same. Not really if you cook, but they're similar enough that we could substitute them in for each other. They have the same value in a recipe. Now these are the same, x and -7, which means in this other equation, we could put a -7 in for x. So I'm going to rewrite this as 4 times -7 plus 6y equals 20. So what I did is I took out the x and I put the -7 in its place because I knew that x and -7 were equivalent. They're the same. So I could replace the x with the -7 and that's okay in this system. So now I can simplify this to get the value of y. 4 times -7 is -28 plus 6y equals 20. Then I can add 28 to both sides, trying to figure out what y is, trying to get y all by itself. So that goes away. I have 6y equals 48. Now 20 and 28 is 48. A little bit better. Maybe I can zoom in a little more too. And then I can divide both sides by 6. So y equals 48 divided by 6 is 8. So I know that if I were to graph these two lines, they would cross when y is 8. And to figure out what x is, I actually don't have to do any more work here because it already tells me that x is -7. So these two lines are going to cross when x is -7 and when y is 8. It's called substitution because we take what one variable equals and we substitute that value into the other equation for that variable. So this was step 1 right here, substituting -7 into the other equation. This is step 2, solving to find the value of the first variable. And step 3 we didn't really have to do because it already told us what the value of the other variable was, -7. If you come down here, that's not the case, though. It doesn't tell you exactly what one variable is. So we need to do a little bit more work to figure it out. The first step is to substitute in. So I know that y is the same as 2x minus 6. Those two things are the same, y and 2x minus 6. I know they're the same because this equal sign tells me that they're the same. That's what an equal sign does. It says this and this are the same thing. They might look different. These look very different. Y does not look like 2x minus 6, but they have the same value. So because they're the same, they have the same value, we can swap them in and out for each other. So in this other equation, I can't get the value of x or y because I don't know what x or y is. I will need to know x to get y, and I need to know what y is to figure out what x equals. But I don't know what either one of those equals right now, so I can't solve that. So to get the values of x and y, what I'm going to do is I don't know what number it is, but I at least know that y is equal to 2x minus 6. So I'm going to rewrite this second equation as this. I rewrote it, but instead of the y, I put in a 2x minus 6. This was my y. Okay? It said negative 4y. Now I have negative 4 times 2x minus 6. And I want to make sure to put this in parentheses because this negative 4 here is being multiplied by all of y. And this is all of y. So we want to make sure that we multiply this negative 4 by all of this. And we do that by making sure that it's in parentheses. So now I simplify. First I need to distribute. So negative 4 times 2 is negative 8x, and negative 4 times negative 6 is a positive 24, equals 14. And then I need to combine like terms. I can add these together. 3x and a negative 8x and a negative 5x plus 24 equals 14. Notice I'm rewriting it every time. That's really helpful. Then I can subtract 24 from both sides. So that goes away. I have negative 5x equals negative 10. Then I divide both sides by negative 5. And I have x equals 2. So I know now that wherever these two equations cross, the x value is going to be 2. Now I just need to figure out the y value. I don't know what y is, but I do know that x is 2. And I know that y is 2 times x minus 6. So what I can do is I can say, okay, well, if I know that x is 2, let's put it right there and see what y is. So y, instead of 2x minus 6, I'm going to say 2 times 2 minus 6. So this is really 4 minus 6. So y is negative 2. So this is my answer. If I were to graph these two equations on a calculator, I would know that they cross at the point 2, negative 2. And that's the way that you can solve systems of equations without graphing them.